This video is a summary of chapter 10. I prepared some examples to show you how to perform a hypothesis test about the proportion of the population or the mean of the population. Although when you do the work online, you are introduced to two methods. One is called the critical value method and the other one is called the p-value method. However, on the test, you can use the p-value method, which requires the use of the calculator. You would notice that the p-value in some of the work that you do in the book online is calculated using tables or some other techniques. However, on the test, you can simply use the hypothesis testing tests that are available to you and get the p-value. Why the p-value is so important? Because based on the p-value, when you compare it with the level of significance alpha, you can decide to reject HO, which is a null hypothesis, or fail to reject HO. The whole problem that you do is about deciding whether you reject HO or fail to reject HO. Based on your decision to reject HO or fail to reject HO, you can write the conclusion and the context of the claim in words. So I prepared 5 questions. I think that they do cover everything that you need to know in this chapter. I'm going to begin with the first one, and I'm going to show you how to use the calculator to do the question. Okay, the first one is the proportion of college students who gain weight their first year is at least 65%. To test this, researchers sampled 200 students and found that 120 had gained weight their first year. Use a 5% significance level. Alpha is 5%. This is the maximum allowable probability of rejecting HO when it is true. So this is the probability of making a wrong decision. Okay, as you notice, you have to state the null and the alternative hypotheses. You have to calculate the test statistic. You calculate the p-value. You make your decision to reject HO or fail to reject HO. And then you write your conclusion in the context of the claim. So I'm going to scroll down now and show you to the solution part and show you how to use the calculator to derive the solution. Okay, so we have X. As you can see, it's 120. This is the number of successes. The sample size is 200 and the significance level alpha is 5%. Now, how do you set up the null and the alternative? What does at least means? At least means greater than or equal. If you have a greater than or equal, or less than or equal, you must put that in the null hypothesis and you must only put the equal sign. So what goes in the null hypothesis is always the equal sign. So whether you have a less than or greater than or equal, that will go to the null hypothesis and equal sign. Now, what's the complement or what's the alternative to greater than or equal? It's less than. So that's why you see in H1 I put P less than 0.65. Now, where is the claim? The claim is in the null hypothesis because he says the proportion is at least. And since at least includes an equal sign, so it goes to the null hypothesis. When the claim is in the null hypothesis, when you write your conclusion at the very end, you either say you have enough evidence to reject the claim or you don't have enough evidence to reject the claim. You can never use the word support when the claim is in the null hypothesis. You notice in H1 I forgot to put the column, so make sure that you do that. How do you perform the test on the calculator? So we'll turn the calculator on. We go to Stat. You go to Tests. And for the proportion, guys, this is one function. It's called one prop z test. Press enter. Okay. Now, P0 means what is the assumed value in the null hypothesis? Well, it's a 0.65. So I'm going to put 0.65 and press enter. X is the number of successes. 120. Always x is less than n. N is 200. And then enter. And now prop. You have to choose the alternative hypothesis. The alternative hypothesis is less than, so I'm just going to scroll to the next one and press enter. And then you can hit calculate. Okay, here you go. You get the test statistic. In the book it's called Z sub 0, so you can name it Z sub 0 if you like. It's negative 1.48, so that's negative 1.48. You have to have 2 digits after the decimal point. The p-value, which is the big number here, which is the key value here, is 0.0691. We need 4 digits after the decimal point. Now step number 4, guys, ask yourself, is this p-value bigger than alpha or less than alpha? Well, you know this is 6.9%, which is bigger than 5%. If the p-value is bigger than alpha, larger than alpha, you must fail to reject HO. Now, the most important step, the last one for a reader. Well, since you fail to reject HO and our claim is in HO, you just say that there is not enough evidence to reject the claim. And that's exactly what I said. There is not enough evidence at the 0.05 level of significance to reject the claim that the proportion of first-year college students who gained weight is at least 65%. And this concludes the first exercise. Now we're going to go to the second exercise. I'm going to take you back to the problem. Here we go. Number 2. The standard treatment for a disease works in 0.675 of all patients, which is, if you convert it to a percent, 67.5% of all patients. A new treatment is proposed. Is it better? The scientists who created it claim it is. You, as an advocate for a patient or sales personnel for the company that eventually would market it, must be more skeptical. Where is the data? An initial clinical trial of n equals 100 patients of similar general health is conducted. 77 people are cured. Assume that the selection of patients is random. Test appropriate hypotheses at the 1% significance level. So alpha is 1%. When he say is it better, that means the proportion of people who benefit from treatment should be more than the current proportion, which is 0.675. So let me take you down to the statement of HO and HA, H1, and then we will go and show you how to use the calculator to do this. So he wants to know if it is better. So that means if the proportion P is greater than 0.675, which is the claim. As I told you in the previous exercise, the null hypothesis must have the equal sign. You have n equals 100, x is 77, and alpha is 0.01. It's the same test, the proportion Z test. So let me take you to the test now. Stat, tests, proportion Z test, enter. Okay, I'm going to change this to 0.675. Enter. X is 77. N is what in this case? 100. Don't mix up X and N. X is smaller always than N. And what are we selecting here? The third one. Okay, calculate. Here you go. So I got Z, the book uses Z sub 0, so you can use Z sub 0 if you like, with 2 digits, 2.03. And the p-value, as you can see, is 0.0213 with 4 decimal digits. Since you notice that the p-value, which is 2%, more than 1%, which is alpha, so you fail to reject HO. Now, if you fail to reject HO and the claim is in H1, you say there is not enough evidence at the 0.01 level of significance to support the claim that the new proposed treatment for a disease is better. I've already communicated the 4 possible scenarios and how to state your conclusion based on whether you reject HO or H1 to you. So make sure that you understand how you make the statement at the very end. So that was number 2. Let's go to the next one. 3. Okay. It is not about the proportion anymore, it's about the mean, which is, I believe, this is section 10.3 now in your book. But we're testing the population mean now. A machine is designed to fill jars with 16 ounces of coffee. A consumer suspects that the machine is not filling the jars completely. They sample 12 jars shown below. Is there enough evidence to support the consumer's claim? So what is it the consumer is saying? If the machine is not filling the jars completely, means it's doing less than 16. So this is where the claim is. So the claim, since it's less, then it should go to H1. And as I told you, HO will always be the equal sign. So let me show you the first step. And we need to test the claim as 10%. Okay. So mean is 16, and H1 mean is less than 16 ounces. And this is where the claim is. Okay. What do? We'll go to the calculator first, stat. We press on edit. And we enter all the raw data that's given to us. I've already done that to save time here. After you put it in L1, you go to stat again. You go to tests. And it's a t-test. T-test. We use t-test to test the population mean when the population standard deviation is not given in the problem. Here he just gave us information from a sample. So it is a t-test. When you have a raw data set, guys, it's very, very likely it's going to be a t-test always. So enter. Okay, input. Is it data or summary? I don't have a summary. He gave me the actual data. So I select the first one. It's been selected already. Mu0, we put 16. Okay, is your list in L1? I'll leave it in L1 here. Frequency, do not change this one. It's always at 1. Now, the last one is the alternative hypothesis. What's the alternative hypothesis here? Is less than. So I'm going to go to the middle one, enter. Okay. And then I'm going to hit calculate. You can do a draw or calculate. It doesn't matter. Okay. So I get T, which is the test statistic. You see, it's called T, not Z here. In the book, he calls it T0, T sub 0, which is fine. You can use either one. Negative 1.780, 3 digits. P-value is 0.0514 if you do 4 digits. The p-value, as you can see, guys, is less than 10%, which is alpha, so we reject HO. If you reject HO and your claim is in H1, you support the claim. So you say there is enough evidence at the 0.10 level of significance to support the consumer claim that the machine is not filling the jars completely. What does that mean for people or company who owns the machine? They have to go and fix it because there are issues with the machine. So that's number 3. I'm gonna take you to number 4 now. Number 4. A physician claims that joggers' maximal volume oxygen uptake is greater than the average of all adults. So like greater than means the claim should go to the alternative because it has the greater than sign. A sample of 15 joggers has a mean of 43.6 milliliter per kilogram and a standard deviation of 6 milliliter per kilogram. If the average of all adults is 36.7. So he's asking us to check if the maximum volume oxygen uptake for joggers is greater than 36.7. That's the claim. Is there enough evidence to support the claim at alpha equals 0.01? So let me take you down to show you how we stated the null and the alternative hypothesis. Okay. The alternative, we want to test if the mean is greater than 36.7, and the null, as I told you, it's always the equal sign, and the claim is in H1. Now what do we have? We have N, so let me go, it's a t-test again. So we'll go to stat, tests, t-test, enter. Okay, I don't have data here. I have the summary. It didn't give me the actual data, so I select stats. Mu0 is 16, 36.7. Okay, here. We're testing against this value. Remember, guys, in a hypothesis test, we always assume the null hypothesis is true until proven otherwise. Okay, what do we have? X bar, what was the mean from the sample? 43.6. S, sample standard deviation, he said it's 6. N, how many in the sample? 15. What's the alternative hypothesis? The alternative hypothesis, as we said, it's greater than. Enter. Here you go. So I got the test statistic. You can put T0 or T. The book, I think, uses T sub 0. So 4.454 is 3 digits for T. P-value is 0. Oh, you can see the p-value. It says 2.726 E negative 4. Please do not ignore the E negative 4. A lot of students in the past would ignore it and write a p-value as 2.72. P-value is a probability anyway. It can be more than 1. E negative 4, guys, means you have to move the decimal point 4 digits to the left. So make sure to do so. It will be 0.00027. You can actually put 0.003 because I said it's only 4 decimal digits. Well, the p-value is so small, it's less than alpha, we reject HO. Well, we guys reject HO and the claim is in H1, so we support the claim. And here's what I said here. There is enough evidence at the 0.01 level of significance to support the claim that the jogger's maximum volume oxygen uptake is greater than the average of all adults, which is 36.7 milliliter per kilogram. Okay? We're going to go to the last question, number 5. That should be a very good summary, guys, for everything you're doing here. Number 5. A teacher claims that the boys in her classes are taller than the average 69 inches for boys in this age group. So the claim is the mean is greater than 69. So it's going to go in the alternative hypothesis because it's a greater sign. A sample of 30 boys had an average height of 70.4 inches. If the population standard deviation of the weight of all boys in this age group is 2.75 inches, is there enough evidence to support the claim? Did you notice in this exercise that the population standard deviation is given in the problem? If the population standard deviation is given in this problem, you must use sigma, you must use a z-test. So again, guys, this problem is different. He gives you the population standard deviation. When he gives you the population standard deviation and you're doing a test for the mean, you must use a z-test, not a t-test. Okay, let's go to scroll down and see how to start listing the conditions of the problem. Okay, so we need to test if the mean is greater than 69 inches. Okay, great. So we put mu greater than 69 inches. And again, the null hypothesis is always mean equals 69. Let's go to the stat, tests. You see, I'm going to choose z-test this time. Most of the time it is a t-test, but when he gives you sigma, it's a z-test. Mu 0. We're testing against the value 69, so I'm going to enter 69. Sigma, you see here, what is sigma here? 2.75. X bar, what is the sample mean? 70.4. N, what's the sample size? 30. Assume it is a random sample. And we're testing that the mean is greater. Remember, the last step before you hit calculate is what's the alternative hypothesis sign. Has nothing to do with the claim. It's what's the sign in the alternative hypothesis. Calculate. Okay, z is, or you can use z sub 0. 2.788, we round it to 2 digits, 2.79. The p-value, as you can see, it's very small, 0.0026. The p-value is less than alpha, which is 10%. So if the p-value is less than alpha, what do we do? Reject HO. And if the p-value is more than alpha, we fail to reject HO. Remember that. So what do you say? If you reject HO and your claim is in H1, then you support the claim. And he asks if you can support it, then you say yes. There is enough evidence at the 0.10 level of significance to support the claim of the teacher that the boys in her classes, it's not just one class, all classes, are taller than the average 69 inches. Again, the null hypothesis should always have the equal sign, and the alternative hypothesis will have either greater than, less than, or not equal to. It happened that in all of the exercises I picked that there was not equal to, so we didn't do any, but it works exactly the same way. So I hope that this video helps give you a very good idea of what you are learning in chapter 10, which is hypothesis tests for the means and proportions of the population.